Welcome to Maths and Science by IITian channel. Today I will be taking up dot product and cross product of two vectors. What is the dot product? What is the cross product? I will explain now. A vector can be represented as, let us draw a diagram. This is x-axis, this is y-axis. There is one point P, it is x1, y1, and another point Q. Here it is x2, y2, and here this distance is x1, here this distance is x2, here this distance is y1, and here this distance is on y-axis, it is y2. And O is the origin. From origin, we will connect the point P and point Q. OP, vector OP, if we call it as P, that will be position vector of point P with respect to origin. OQ is equal to Q, vector Q, that is position vector of point Q with respect to origin. That means position of point P with respect to origin and position of point Q with respect to origin. OP and OQ are the magnitudes, and vectors OQ at an angle of theta 2 and OQ at an angle of theta 1 with respect to x-axis, positive x-axis. OP and OQ, they can extend either side. Vector direction, they are vector directions. Whereas O is the starting point for the chosen vector, P is the ending point, and OP is the magnitude of that particular vector. And OQ is the magnitude of this particular vector. You can choose any magnitude. There is absolutely no problem. Vector has both direction and magnitude. That's what we have discussed in the lecture 1. For clarity, please refer to the lecture 1. Now, what is the dot product? Dot product is a scalar quantity. Dot product is equal to a scalar quantity defined as magnitude of P into magnitude of Q cos theta. The angle between P and Q. The vectors P and Q. What is that angle? This is the angle. Angle between OP and OQ. This angle between OP and OQ can be theta is equal to theta 1 minus theta 2. Theta 1 is the angle for OP, and theta 2 is the angle for OQ, and theta is equal to theta 1 minus theta 2. The angle between the two vectors. Angle between two vectors. If theta is the angle between two vectors, then dot product is defined as magnitude of P into magnitude of Q into cos theta. And the definition of the cross product is equal to, it's a vector quantity, magnitude of P into magnitude of Q into sin theta into a normal vector to the plane of P and Q. To the plane of P and Q, a normal vector. This is the meaning. Please understand this meaning. N is the normal vector perpendicular to the plane of P and Q. That is the meaning of the cross product. Now, we require little bit of further description on cross product. Let us say a plane is like this. It's a plane. A plane resting on a triangle resting on a plane. And this is origin. And this is P. OP vector. And this is Q. OQ vector. And a line perpendicular to the or normal to the plane of OPQ. This is the line perpendicular to the plane. This is the plane. Please visualize the plane. This is 90 degrees. This whole is a plane. This triangle is on a plane and a line perpendicular to the plane of the triangle where it is resting. And if OQ is one vector and OP is another vector, then OP cross OQ is equal to OP magnitude, OQ magnitude of OQ into sin theta into unit vector normal to the plane normal to OP and OQ. OP and OQ is a horizontal plane in which a triangle is there, and OP is one vector and OQ is another vector, and a plane perpendicular to the horizontal. This is perpendicular to the horizontal at 90 degrees to horizontal, this N plane, and it's a horizontal plane. And this OP and OQ, OP is also 90 degrees, OQ is also 90 degrees because it is perpendicular to the plane of the horizontal plane where OP and OQ are lying. OP and OQ are lying on a horizontal plane, and N, the vector N, is lying on a line perpendicular to the plane, horizontal plane where OP and OQ are lying. This is the meaning of cross product. Now, we understood what is the dot product. and dot product, and what is the cross product. Dot product is AB cos theta half this PQ cos theta, and cross product is magnitude of OP and magnitude of OQ into sin theta into normal, because it is a vector quantity. Cross product is a vector, dot product is a scalar. For dot product, the geometrical interpretation is, here is O, reference point, and one point P is here, another point Q is here, Q is here. OP bar is one vector and OQ bar is another vector. The definition, OP dot OQ is equal to OP magnitude of OP into magnitude of OQ into cos theta. This is theta. Theta is the angle between two vectors. This is OQ cos theta is nothing but this. OP cos theta is nothing but this one. OP cos theta into OQ. This is nothing but OQ into OP cos theta. Either way we can make it. That means ultimately cross product is equal to, in terms of sin theta cos theta, cross product is OP OQ into sin theta. Because it is a product, a perpendicular normal to the plane of OP and OQ is drawn. That is the direction, unit direction of the normal. And dot product is equal to OP OQ into cos theta. It is, because vector is there, it's a vector quantity. It is a scalar quantity. Why it is a scalar quantity? Why it is a vector quantity? I will give the explanation now. Cos theta is equal to cos minus theta. That is equal to cos theta. That means irrespective of the angle, whether it is positive or negative, cos theta is equal to cos minus theta. Implies cos theta does not depend upon the direction of theta, whether it is minus or plus. Hence, it does not have a direction. Hence, it is a scalar. If something changes because of the sign of the angle, then that is called as vector. Whereas sin minus theta is equal to minus sin theta. Implies it changes with sign of angle. Hence it is a vector quantity. Hence cross product is a vector quantity, dot product is a scalar quantity. I will give an example for dot product. You find the example for cross product in physics. The example is force is a vector. Force is a vector. And displacement is a vector. F dot S is equal to F S displacement cos theta is equal to a scalar quantity. But F dot S is nothing but work done. Work or energy. Therefore, dot product of two vectors, force F bar and displacement S bar is a scalar quantity is called work or energy. Hence, work or energy is a scalar quantity, F dot S. Similarly, you give an example for vector quantity. I will give it, you try to understand it, get some more examples like this. As a homework to you. L is equal to R cross P, where P is the linear momentum, R is the displacement, it can be radius, and L is the angular momentum. LRP is one of the, L is equal to RP is one of the, you cannot change the order of the vectors in a vector product. Vector product. You find out the dimensions of L, dimensions of R and P, and go into the definitions and get detailed about L is equal to R. Similarly, if you find any more vector quantities like this, product of two vectors is equal to a vector, you please list out them. That you treat it as a homework. Now, till now what we have done? In the lecture 1 and lecture 2, defined the vectors, Cartesian coordinate system, understood. Third, two vector products are defined with angle between them cross product and dot product are understood. If this video has added any value, addition to your knowledge, please subscribe to my channel Maths and Science by IITian. Please share, view, review, comment for any doubts regarding vectors. In the next class, that is vectors 3, the Cartesian coordinates are taken, that is components of xy instead of theta. Will resolve the dot product and cross product. Cross product will be the determinant of the matrix. Dot product will be multiplication of respective components and their summation. We'll dwell into that in the next class. Thank you for listening to me. Best of luck to everybody.